Hi everyone. Today I want to just kind of look back at the Pythagorean theorem. So I think you should remember that a squared plus b squared equals c squared for any right triangle with legs a and b and hypotenuse c. So if I was to use the Pythagorean theorem to find c here, hopefully you would do 5 squared plus 12 squared equals c squared. And if we finish that up, we're going to get 25 plus 144 equals c squared. So 169 equals c squared. We take the square root by doing the inverse operation, and we get c equals plus or minus 13, but we would throw out the negative because we're talking about length. So c would be 13. Okay, if I did that same thing here, you should notice it's an integer. We don't always get integer values, okay, but it is an integer. Here, if I do that same thing, I'd be slightly modifying my equation because it would be 3 squared plus b squared equals 5 squared. 9 plus b squared equals 25. So b squared equals 16. And so b would be equal to plus or minus 4. Again, we would throw out the negative answer because it's length. And then this last one, if I did that same thing, I would do a squared plus 15 squared equals 17 squared. Going through that process, I get a squared plus, 225 equals 289. And so a squared equals 64. And a equals plus or minus 8. Again, I'm going to throw out the negative answer, so it would be 8. These are what we refer to as Pythagorean triples, meaning that these three lengths, these integer values, all come up together in a right triangle. So if I know that I have a leg 5 and 12, I know the hypotenuse is going to be 13. So why is this important? Well, when we get into trigonometry, these Pythagorean triples come up all the time. It saves you the step of the Pythagorean theorem. All right, so let's look at some of those triples. We have 3, 4, 5. We have 5, 12, 13. We have 7, 24, 25. And then we have 8, 15, 17. Now, what's important to recognize, and you should have done this in your geometry class, is that any multiple of these is also a Pythagorean triple. So 3, 4, 5, I could say 6, 8, 10. Multiply them all by 2. I could say 9, 12, 15. These would also be Pythagorean triples. Now there's a couple interesting patterns. There's actually a ton. But one that we investigated in our Algebra 2 honors class was the fact that these values, if the smallest side was odd, they noticed that these two values were consecutive integers. That means right next to each other. They also noticed that if you added them, 25 and then 49, that their sum was this number's square, which is true. So we were able to identify a couple additional Pythagorean triples. We said, okay, if the next short leg is 9, then we know that the sum of these has to be consecutive. It actually has to add to 81. So 40 and 41. Now that pattern does not hold with an even short leg. But again, these Pythagorean triples, guys, if you know them, they're going to be really helpful throughout the trig unit and beyond. So just a short video to kind of recall those Pythagorean triples. I'm going to bring them up a lot because I'm probably not going to use the Pythagorean theorem when these numbers come up. All right, have a great day.